Thank you. So, good morning, everyone. I appreciate everyone showing up for my talk today. It is a pleasure to be back in Vienna. This is my fourth trip to Austria. I love Vienna and Austria. It's always a lot of fun to come back and visit. Like I said, I'm Paul Coggin. I live in the States in Huntsville, Alabama. I work as a red team engineer where my responsibility is penetration testing every day for a very large financial firm. My background, got over 20 years experience, focused on routing and switching, networking, telecommunications, service providers, and large enterprise networks. And so I try to specialize on trying to either build, defend, and hack networks. So that's where I come from. And what we're going to talk about in this presentation is some things that I've seen specifically from my consulting engagements, where I previously spent over 15 years doing consulting, going and testing different networks around the world, and seeing a lot of problems that were being missed and overlooked by the network security audit teams that were doing compliance testing, vulnerability assessments, penetration tests, and the guys who were trying to defend the networks. There's just some common basic fundamentals that were being missed by highly skilled, highly trained security teams, and I just couldn't get over what I was seeing. We're, for example, going into networks that running both, Brocade, Cisco, Juniper, what have you. The real nice, very capable blinky lights. Pick your favorite vendor. But and they had all the features to secure the network infrastructure, but none of those features were ever turned on from my testing, and they were never going and validated and tested by the security team. So it was obvious to me that there's a gap in the training and the certification and experience in the industry. So I wanted to go put some light on this and put on the layer 2 and of the OSI model here that we're overlooking. And you guys that are getting started in security assessments and penetration testing, this is some low-hanging fruit for you where you can go in on a part of your team and find some high-level vulnerabilities. Because like I said, I was on an assessment in my previous organization, and I was finding like 8 high-level vulnerabilities just with Wireshark at layer 2 here. So this is one of the inspirations for this. And one example here that's being missed is real simple when we do network architecture reviews to go in and look at how a client's network is architected, give them recommendations on how to improve their posture, add new features, capabilities, and services to the network. We'll go in and look at the network, and they always give you a network drawing. It's 2 or 3 network engineers, old, and it's probably got pizza stains on it, or they could draw you something out at lunch on a napkin because they don't really have a good up-to-date network drawing. So we'll go in and use something like the CDP protocol on the Cisco network or LLDP on other stuff to map out the layer 2 and discover what devices we're connected to. And it's a really good, robust protocol for doing that. But as I want to show you, is it when you're sitting on the network device, you can go out and map who you're connected to and see that you're connected to, a router, switch, what ports, interfaces, what version of code they're running, and you can go and validate their network drawings. But from a security standpoint, this is leaking out some really good intelligence for your adversary, whether they're an insider or you're getting audited. I've seen this information bled out where a service provider misconfigured a Metro Ethernet switch where they were aggregating lots of customers, and the engineer misconfigured the Metro Ethernet switch, and all of a sudden one of my engineers took a screenshot where he was able to see financial firms, healthcare firms, all kinds of organizations, network infrastructure, what they were all running via this CDP protocol because it was misconfigured and they were all multicasting this out on the wire on their WAN link. And in this case, what I'm showing you is an example of catching CDP and being able to see the version of a router code that's running on the router. I taught a class The workshop I taught here at DeepSec this week, I taught it in the US a while back, and while we were there, one of the students just pulled up Wireshark at the hotel. You know, we're at a hacking conference, and they got letting us on their wireless. Student pulls up Wireshark, and I'm talking about this, and he goes and pulls up the version of code on one of the vulnerability databases, and that particular router had 5 major vulnerabilities. They're been patched, and they're just pushing that out there for anybody that looks at it. Now, nobody did anything with it because it wasn't authorized, but it's just an example of information leakage. It's low-hanging fruit that's being missed. And apparently this organization had a new network and had been secured, and we're sitting there running a conference, and they're bleeding out all this information about their network that somebody could go and directly attack their network infrastructure, for example. This is just low-hanging fruit, the basics. Now, here's something that I'm seeing a lot more of, multicast. If you haven't dealt with multicast yet, let me give you a real quick overview. Multicast is becoming more and more popular in our networks. It used to be you'd only see multicast for device protocols, like your routing and switching protocols, but now you're seeing more and more multicast for applications where the multicast traffic is traversing routers. And what you have is with multicast, if it's implemented for an application, instead of doing a one-to-one traffic stream with the multicast, we can do a one-to-many to use less resources off of the source infrastructure and the network. And so up at the top, you see where you might have the multicast source that is streaming traffic. A popular application that I was implementing in the US in my previous role was IPTV, where we were streaming cable TV over IP and mapping cable TV channels to multicast address. And so we'd have cable TV encoders that would convert the channel to IP, and so when you're clicking your remote, you were changing IP multicast groups. And so that's an example of an application you might have that's going to stream in, and it's going to hit the routers, and the routers are going to build a tree of the best path for the optimal path for multicast traffic through the network. And one thing with the multicast to understand, you guys that have a basic understanding of routing, but may not be familiar with multicast, where your normal routing is based on the destination, forwarding traffic to the destination. And the multicast, before it will forward the traffic on the router, it will go and verify the source, that there is a path back to the source, and that's a rule called reverse path forward. Just something else to know about some basic fundamentals of multicast and routing. And the multicast will utilize whatever routing you have developed in your network, whether you've implemented static routes, OSPF, EIGRP, et cetera. The multicast routing is going to be dependent on your routing protocol that you have implemented. And then as you go down into the network, you're going down into your VLANs, then your end user devices, your Internet of Things. Internet of Things is going to be an application that's going to drive multicast with all the Internet of Things sensors. I can see that being a big application for multicast. And so that's going to run like IGMP version 1, which is an old version. What you're probably going to see is like version 2, and your implementation is IGMP version 3 on the network. And you'll see ICMP with V6. And so with the users, the IGMP will send up a request to the router and let the router know that it wants to join a multicast group and pull the stream down to it. And this is what you're going to see on an example in Wireshark. This is one of the things I want you to walk away with. I'm seeing this missed by guys who have all of the cutting edge hacking certifications. They're missing this low-hanging fruit. This is real basic stuff, and it's totally being overlooked. What you're going to see in the Wireshark, you want to go and pull up Wireshark as soon as you start testing, especially if you're on site. And one of the examples you'll see is this IGMP. If they're running the multicast, say they got the Internet of Things, some other applications, you're going to see probably a version of IGMP running on the network. And that should trigger you that you need to go and assess that to see if they've secured the multicast. In addition, what you may see, especially if it's a larger network, you might see the PIM protocol, and PIM is going to be the multicast routing protocol. And there's multiple versions of PIM, the algorithm that might have been implemented, but you'll probably see PIM 1, PIM 2, PIM2 is most likely what you're going to see down into the VLAN if the network guys have not hardened their multicast. And in most cases they have not. And what you're going to have is an opportunity. If you can see it, you can possibly manipulate it and interact with it. And we'll get into some examples here. So how we're going to attack this multicast. Now, depending on the attack vectors in the network, you got to be careful because you could possibly introduce a denial of service attack depending on what your method is. So you want to make sure it's in your rules of engagement. It may be that you just have to document that, hey, this is a possibility, and make note of it and not actually go and attack it because, and my rule is when I do secure pen testing, if it's going to light up the help desk phone and somebody's going to start experiencing problems, we don't do it because that's going to cause a problem for the project. And we'll just document it. Maybe go test it in a lab. So some things we could do is like for the IGMP that you're going to see down in your end user network, that layer 2 where there's maybe where the receiver, maybe it's the sensor or the end user's trying to join different multicast groups. Maybe we could go and spoof IGMP requests and pull and send requests and pull multicast streams that we weren't supposed to get. Maybe we could pull more multicast traffic than the network can support, for example. And we could craft those packets, craft those requests with tools like SCAPI, Colosoft Packet Builder would be easy ways to do that. And at the same time, that PIM protocol that we just looked at, what about going and acting like a PIM router, acting like a Juniper, Cisco, Brocade router, and introducing and sending our own PIM packets into the network and try to extend that network. And maybe we go and start sourcing traffic and feeding our own multicast traffic into the network with an alternative stream than what the users across the enterprise or service provider network wanted. Depending on the rules of engagement, that's all on the table, but it's still a vulnerability whether we actually do the attack or not. It's something that needs to be called out. So it's totally possible that we could act like a multicast router or, like I said, go and manipulate the traffic streams from a host standpoint. Because the receiver, think about it, your end users' devices down in those VLANs, they're not routers. So why should they be seeing that routing traffic? We've got to go. A big problem I'm seeing across the industry around the world is not going and treating the network and looking at it from a control plane protocol, a management protocol, and a data plane protocol. In these device-to-device protocols are your control plane, and if your end users, those end user VLANs, if there's not a network device there to interact with, they should not be seeing that protocol. We should secure that and lock it down, as well as lock down that management plane. So some things we could do to secure it. Since this multicast runs UDP, it's real easy to spoof UDP and craft UDP packets and spoof it because we don't have to keep up with the two-way handshake, the state that TCP requires. So it's real easy to spoof UDP. So we're going to have to go and implement layer 2 and layer 3 anti-spoofing. Some networks I may go into and I may see where there might be, layer 3 security has been implemented, but it's very rare that you'll see the layer 2 port security being implemented. So it's a big problem. And implementing access list, basically firewall rule sets, filters at the routers to control who can interact with the control plane protocols, go and lock that down, and go and use your quality of service to control the amount of traffic that QoS, implement QoS to control the amount of multicast traffic that can be streamed into a network to keep from taking a performance hit. And at the same time, go in and on these switches, go in and limit the amount of broadcast and multicast traffic on those switches to keep a denial of service from happening. I saw a multicast attack happen. It was totally accidental, but There was a developer at a very large enterprise, and he was doing what developers do, writing code and testing it on the production network. Because after this event, they have a lab for the developers to test code with. But at this time, the developer did not have a lab to test his code on. He was developing a multicast application for a new product. Started testing his application. One developer rolled the whole enterprise network down with a large group of highly paid engineers out of work, all the network guys running around acting crazy trying to figure out what took the network out. And there was one developer with a multicast application, rolled the whole network out. And so we need to go in and do storm control on these switches. We bought the features. We might as well use them. We paid for it. And another example, I'm aware of one event in Europe and an event in my backyard in the U.S. where major critical infrastructure got taken out because this simple feature was not implemented by the defenders, by the blue team, to limit broadcast multicast storm on their network. It rolled over a major critical infrastructure. Here's another example we need to be looking at and auditing in our networks is the dynamic trunking protocol, where the switches are left at their defaults to auto-negotiate. Auto-negotiate is evil. Do not do anything with auto-negotiation. Always want to go and be deterministic and lock in whatever speeds and features you want. And trunking is an example of that, where a lot of times it's going to be left dynamic because if because you're plugging in access points, you're plugging in IP phones, say maybe Internet of Things devices that you might want to appear in multiple VLANs and negotiate. But those end users, your end users with their laptops and desktops, there's no reason for them to be able to interact with your switches using the trunking protocol. It'd be a very rare occasion that they would need to be able to do that. And because that's available and it's left in default in many of the networks that we will go out and audit, that gives us an opportunity to go in and spoof a switch with a tool like your Xenia or Loki, or maybe craft Ethernet frames to craft a trunking protocol with a tool like Scapy, if you're into crafting your own. So one of the things we could do is maybe we have a network with a key server, maybe that we'd like to be able to hit, maybe take out, say with the UDP string, where we could fire traffic one way. We could do double VLAN tagging because this vulnerability is not being dealt with. Maybe we double VLAN tag. Say we're plugged into VLAN 10 and we want to get to traffic over in VLAN 40 over in the right where there's a key server. So maybe you got a disgruntled employee or someone at the company's made mad and they can, and the network's architected so that they could get a UDP packet possibly spoofed into the network. Well, maybe we double tag the VLAN, and when the switch gets that first VLAN 10, it strips it off and it goes on through the network with the VLAN 40 and goes on in, and we'll be able to get a one-way connection. We're not going to get the two-way connection so that you get a shell with Metasploit, but we could craft packets, say like with Scapy or what have you, and spike a packet into the server. I worked on a scenario where that was all we needed to be able to do. There was a critical operation, and the architecture was, it was depending on nobody being able to get a UDP packet into that enclave. And we were able to prove that we could not only get traffic into that enclave, but we could knock out that system and cause denial of service and take out a critical piece of hardware by doing this. Now this is something that's very low-hanging fruit. If you haven't seen this, especially in large organizations where they have attention toward redundancy, where availability is very important to them, where they have multiple sets of equipment. And you'll see this in your Brocade, your Juniper, your large Cisco networks. I actually worked on a network where the customer had three very large networks, three different manufacturers. He had a Juniper network, a Cisco network, and a Brocade network. And three different contractors implemented it, and they all three implemented it unsecure. And on the Cisco network, they use the HSRP protocol, and on the Brocade and the Juniper network, they use the VRP, the Virtual Redundant Router protocol. And what you have is you have two routers, they're sitting parallel with each other, and they're sending a heartbeat between each other, and they're multicasting out the respondent for the default gateway for the network, what you're sending out in your DHCP. And if one router is your primary and one router is a secondary, and the primary router, if it drops, the secondary router will automatically pick up because it misses that heartbeat. Now, what you're going to see typically out in the field is, in my experience, I've been programming routers since 1997, and I have yet to see redundant routers running these protocols be implemented securely. And most likely, what you're going to see 90% of the time is no authentication. Where there's no authentication, and all you need to do is jump on the wire with your router, go your GNS3, your Cisco Virl, maybe maybe you fire up some other environment, say Huawei ENSP possibly, and you can interact with the router. And here's an example of looking at the Wireshark where you'd see where they'd have a password. If they have a password, it's always going to be clear text. I'm telling you, since '97, I've never seen a hashed encrypted password on these protocols. It's just a network. Your network may be encrypted, but everyone I've ever plugged into, it's not encrypted. And it's typically, and if they have a password, it's going to be typically the vendor name or the project name or the company organization name, and it's just going to be out there in the Wireshark. It's low-hanging fruit. If they didn't want you to hack it, they shouldn't have put it out there, right? They put it out there for you. So when you're out there doing that network assessment, and it's inside your rules of engagement, we need to go and get this. If nothing else, we need to identify it when we're out there doing audits. Because I'm telling you, I'm going behind vulnerability teams, red teams, pen test teams from other organizations, going behind them, and this stuff is just laid out there, low-hanging fruit, not touched. Everybody's focused on the higher layers, picking on the Microsoft stuff and the web apps, and they're totally missing this network protocol stuff. So here's an example of what you'd see with the Cisco, where you'd have HSRP, and what you show up there at the top is that black and red. Those lines is two routers, 192, 168, 1.1, and 1.2, and they're sending a heartbeat between each other. And you look down there at the bottom, and you see the password Cisco running in the clear. And what you see, what I see is all of us network guys around the world, we all take the same certification classes, we all read the same books, and everybody sits down and they type it in just like they did it in class or whatever the book said, and they use the same passwords. I mean, it's like they don't think, maybe I should not use the password that was in my book in the class, maybe that, much less go and encrypt it. But so here's a real quick and dirty way to go and deal with this. Now, if you prefer, you could do all this with SCAPI. SCAPI is an awesome tool. It's got a great deal of flexibility. But if you're more Windows inclined and you want a quick and dirty proof of concept, this is a really good tool. You could take your PCAP and import it into Colosoft Packet Builder. And what you see up there in that line, it's highlighted in the blue there. I've taken one of the packets for, say, the 1.1, 1.2 router there, and I've highlighted it, and you can go in with this tool, and you can go and pick any of the fields in the packet, and you can change them and edit them. So I've gone in and changed it to one of those router packets, HSRP packets, to .50 for my IP address for the host. And then I go over to the right, and I change the opcode so that I can preempt the operation. And over on the far right, I changed the priority to 255. Because what you're going to see again out in the field is though 255 is the highest priority, and if it's my network, why would I not go and give my router the highest priority, my primary router the highest priority? It's always going to be, I think it's because they're looking at the white papers, config examples out of the books, and they download off the web. They always use something like 100 and 120, things like that. But you can go in, so you're never going to have to worry most of the time in real world about them having the priority 255, it's going to be available to you. And so you can put that in, and then you go up to the very top, and you can go and rebuild your packet checksum, and then over to the right, you can send it, and now you're sending router packets, and the whole network thinks that you are a Brocade or Cisco router. You can do the same thing with like VRP. If it's VRP, you can go and hit the Brocade, the HP, the Cisco, what have you. In this case, we're showing the HSRP, and now you look like a Cisco router running on your Windows box. You can do this on XP, your XP, and you can make all those big expensive routers, big as a door, all stand down, and your box is now the router. Now here's the trick: if you think you're going to possibly do this type of thing in your network testing or to a customer, here's where it falls apart. You've got to remember to turn on IP forwarding on the attacking host, or you're going to light up that help desk like a Christmas tree, because all the end user traffic is going to be redirected to you, because you're going to be the default gateway. This is going to work. It works. And all that traffic will be redirected to you, and so you've got to remember to turn on IP forwarding and send the traffic out. Otherwise, you're going to be a bit bucket, and then you're going to upset the staff. So be careful about that. Here's another one we're commonly seeing is IPv6. We're running around the world, and everybody says they're not running IPv6 on their internal network. They may admit they may have it implemented at the perimeter, but they also we're not running it internal. We're not running internal until you pull up Wireshark, and you're seeing all kinds of IPv6, like you probably can see it here at the hotel. And the old school way of doing it is if you wanted to see the IPv6, you could type in 86DD, filter on that, but now you can go and just type in IPv6 and filter and see the IPv6 traffic on the network. This is some more low-hanging fruit that I'm seeing being totally missed. What can you do with that? With IPv6, we don't have broadcast anymore. The old school Cain and Abel, Ettercap stuff that you learned in the first day of your first security class. Well, we don't have broadcast with IPv6, so your ARP poison doesn't work anymore. Well, so now we're going to attack multicast, and this is some low-hanging fruit for doing a man in the middle. And it's being totally overlooked and missed, in my experience. The defenders are not implementing port security for IPv4, and they sure have not implemented port security for IPv6. So this is some low-hanging fruit for you guys that are out there doing audits and pen tests. And what we can do is your router is going to be sending out router advertisements, and your host, they're going to be, if you pull up Wireshark here in the network, you're going to see all these IPv6 DHCP requests, and they're looking to learn what the network is. And so that is an opportunity for you to act like the router and tell the host what the network is, and set up a man-in-the-middle attack, and maybe going to start tunneling traffic out of the network using V6. So tools I would recommend that you look at using is Chiron and Evil Foca. I like those tools. THC Parasite's good, or you could go roll your own with Scapy. Similarly, there's the neighbor discovery protocol with V6 in the local VLANs that you could use to spoof two hosts on the network trying to communicate, that you can go in and do your man-in-the-middle attack with. Again, use Chiron, Evil Foca, THC Parasite, they'd all work. And this is something where you're also going to see. I spoke about this a couple years ago when I was here at DeepSec, but I want to bring it up again because we're seeing it everywhere. OSPF, you just pull up the Wireshark. If they're running, if they're a large routed network where they're running Brocade, Juniper, HP, maybe they're running some open source distro for their routing, what have you. Typically, the OSPF is going to be no authentication. It's going to be shooting out into VLAN. And again, why should your end users be seeing your routing traffic if there's not a router in there for the router to form adjacencies with to forward traffic out of? It's low-hanging fruit for the pen test team to go in and start interacting with this router and maybe join the network. If they have a password, it's typically, if it's a Cisco network, it's going to be Cisco, Brocade, Juniper, whatever, depending on what the vendor is. that they've chosen for the network. And you're just going to see it out there in your Wireshark in the clear. I have never, since, like I said, since '97, I never see this stuff authenticated. They learned it in the class. They learned it in the different certification programs for whatever vendor they go through. But nobody ever goes and implements any kind of form of hash. It's all in the clear. And what you can do with that is you can inject, you could go in and boot up GNS3, boot up, say, Cisco Virl, Huawei ENSP, fire up Quagga, you know, the open source, fire up a VM with Quagga on it and start injecting routes. Why not, let me throw this idea, why not go and inject routes for, say, interesting government organizations while you're doing a pen test, if it's in your rules of engagement, inject routes for, say, Google, Microsoft, NSA, Interpol, and they start looking at their logs and you look like some other large organization. They trace their IPs back to NSA, and you're on the inside of the network, and they think they're getting attacked from outside, out in the world somewhere. There's no reason you can't do that because you can look like a router. Similarly, you're going to see EIGRP. If you're plugging in the network, EIGRP is a Cisco protocol for routing. It's a really good protocol. I really like it, but when I see it implemented, it never has the hash for router-to-router authentication implemented. Again, same concept as DoSPF. You could use GNS3, boot up a router, and start interacting with it and leak routes into their network and maybe do a man-in-the-middle attack and source your traffic from some interesting network. Couple things for you defenders. One thing I'm seeing from a layer 2 standpoint is in the DMZ. If we can go and ever break into the DMZ, these DMZs, the networks are flat. They're in really large segments, and once we can get in, we can freely pivot horizontally in the network. You need to go in and do layer 2 security. You've paid for the hardware that has the layer 2 security. You need to do the VLAN ACLs, private VLANs, and lock down that trust relationship. Now, if you can't go in and do, another thing to do, if you got a large layer 2 network and you can't go back and go and resegment it at layer 3, you might go and look at something like VMware NSX, where you could go overlay across your layer 2 network, and because it has really good layer 2 security from what I've seen. Also, from you want to get visibility on these networks, layer 2. If you're not aware of it, you can do packet capture off the routers. You guys that are doing red teaming, I'm seeing when out on the red team doing pen tests, the guys will break into routers and they don't know what to do with the routers. Well, here's one quick idea, if you haven't thought about it, is using the embedded packet capture to capture packets as they traverse across the router and capture traffic directly off the router once you've gained access. But you defenders, I'd highly recommend you go and start looking at doing network taps, because what if somebody has hacked the router, whether it's a red team that's under contract, that's legal and authorized, what if it's the bad guys? See, everybody's doing forensics, doing IR against the Windows and Unix boxes, and they're totally overlooking the network infrastructure. What if I get into the network, of course I'm going to try to get admin and root on everything, but I'm going to go after that network infrastructure. How do you know that what you're seeing in your monitoring is not being influenced by someone else? Put in network taps and drop out your data into an isolated network, so that you know that you got pristine monitoring data coming off the network. Highly recommend you use taps, and it will also help you work through those political situations where the router switch guys don't want the security team into the network infrastructure. Because I'm a network guy, and I can tell you we don't want anybody getting enable access to our routers. It's my router. I don't want anybody in it because you don't know what you're doing. You're going to mess up my routing, mess up my network. So drop in a tap and cut through all that politics. Now, here's some references. You can get a lot more information. There's some good books from Cisco Press on multicast routing I recommend. I'd go check out the LAN switch security, What Hackers Know About Your Network You Don't. It's an older book. It's a great book. People are not reading it and implementing the recommendations. It's been published there for a long time. There's some good information for both blue and red teams. Check out Router Security Strategies book. It's another really good book by Cisco Press. Gives you some good ideas on how to secure that control plane, management plane, and data plane, if you're not familiar with it. And Definitely, if you don't know Eno Ray and the guys at ERNW, you definitely want to go and check out their blog site. They publish a lot of good papers on networking. I have utmost respect for those guys. They put out some really good research. I learned a lot from them. And iOS Hints, Yvonne, if you don't know Yvonne at iOS Hints, the guy is world-class, top-notch network engineer. He puts out a lot of good information that I learn a lot from. So, anybody got any questions? Do we have time? If the slides will be available, and I'll give you the slides. I'll give you the slides for the workshop this week. All of that information, if you want it, just reach out. I'll gladly provide it to you if anybody wants to see it.
Questions? Thank you for the presentation. Have you seen some of these attack scenarios you mentioned in the real life?
No, I haven't. But they're there. I've not seen these. I've seen other layer 2 attacks, but I have not witnessed anyone use them yet. Typically, what I see was the IPv4 can't enable header cap man in the middle by rogue insiders or somebody, a public place where they've gotten access. I'll see that. I haven't seen the IPv6 attacks in my experience yet, though it's low-hanging fruit and somebody's probably doing it and they don't know it and haven't reported it. But it's there. Just because I haven't seen it doesn't mean nobody's doing it. Because nobody else, I haven't seen a lot of people talking about like the multicast.
So most of the topics I've seen you mentioned are also to avoid some network availability issues, yeah? But from a DDoS or the DOS point of view, I have not seen them so far.
No.
Can you repeat the question? I think the micro is...
Yeah, he was asking if I had seen some of these attacks out in the wild. A lot of these attacks are going to come from the inside of the network, an insider threat, or someone's got access to common areas, maybe in public places like here at the hotel. Because you're going most of this you're going to have local access, but it's totally being missed. And if I was a rogue insider and working red team, I'm going to go and use this against you.
More questions?
Well, I appreciate everyone showing up and attending my talk. I hope you got something out of it. I hope it was of value to you. Again, don't hesitate to reach out to me. I'll gladly provide you all the slides from this talk and the workshop this week as well for your reference. And if I can answer any questions, please reach out. I'm always available on LinkedIn, Twitter. I'm glad to respond to any questions you have. Thank you.
Thank you very much.